vicious cycle again. So that's the rest of the 60%. We just didn't get there.
Yeah. An overview of the formation, but now we're going to go into basically a step-by-step process of how photochemical smog occurs. So this is a lot of chemical reactions, so bear with me. Basically what happens is morning traffic, in the morning traffic, nitrogen gas is oxidized. We learned about how it's oxidized. It's in the air and it goes through combustion in the car. It's not produced by cars, but it goes through combustion in the cars, and it's oxidized and forms nitric oxide, and volatile organic compounds are also emitted. In fact, they're the predominant contributor. And in a few hours, this NO combines with oxygen to form NO2 in the troposphere, which is then broken down or absorbs UV light and splits into NO and O. And what happens is that this oxygen combines with oxygen gas to form ozone. So ozone is bad for all the reasons that we'll explain later, and you probably already know. But in addition, it's the one of the it leads to OH radicals, and what happens then is that it can react with these volatile organic compounds to produce peroxy radicals, which continue this cycle. So it's basically like a huge circle. And NO and NO2 can also react with the volatile organic compounds instead of ozone, which results in toxic products such as PAN, which is very, it's like an irritant for the eyes and for the throat. And what results is accumulation of ozone and volatile organic compounds. Here you can see those different colors are all different, what?
Different severities.
Yeah, they're different severities of air and air quality, and the green is good, the yellow is moderate, orange is unhealthy for sensitive groups, red is unhealthy, purple is very unhealthy, and dark purple is hazardous. And it just shows you about how throughout the day the concentrations of it on August 14, 2002. And then this shows you those same colors, mean the same things, and this shows you on August 14th throughout the day of the whole U.S. So you can see that they're concentrated around California and around New York. Okay, thermal inversion layers. Basically, as you go up in temperature, or as you decrease temperature, you're going up in altitude in the troposphere. So decrease in temperature helps to mix the air and disperse these pollutants. And temperature gradients can be inverted such that the air is colder near the surface of the Earth, which is going to stop the convection of the air. This type of inversion occurs during warm fronts and in the areas of coastal upwellings, which are these areas in California and along the coast of Maine, which you can see on the U.S. map. It had some smog in Maine, which Cameron and I attributed to the fact that there's probably some coastal upwellings there. The effects of smog on the environment, like Connor talked about before, acid rain is a huge result of photochemical smog. Nitrogen oxides easily form nitric acid, and together with sulfuric acid, nitric acid is washed out into the troposphere. It erodes buildings, and also it helps with the corrosion of iron and steel, and it also makes bodies of water acidic, which can damage, like any sort of fish or any sort of marine life. It also reacts well with molecules that have carbon double bonds, which is abundant in rubber and any sort of photosynthetic portion of plants, so it can break down leaves of plants. Also on human health, because of PAN and also ozone, which is a strong oxidant, there's a stimulation of the eye, which creates watering eyes or smarting eyes. And it also reacts with the carbon double bonds in the membranes of the nose and throat and respiratory airways. And it also can induce asthmatic fits, which is not good at all. Okay, so here we have a video of how smog can kill in certain parts of the world. And is your computer connected to the internet?
It's probably it might take a second, but we'll hope that it is.
We have the Magic School Bus today, and we're learning about photochemical smog, everybody.
Oliver is our
Driver.
bus driver.
Will be helping us out today.
Yes, he will be.
Driving with no hands.
Nope.
But he wants
Just look
music.
by no hands. Okay, so we're discussing the effects and the formation of photochemical smog, known to Cameron as the Smogalicious cycle. Photochemical smog was identified in 1942 in LA. It was this air pollution that was slightly different from conventional smog. And during the early 50s, a professor at Caltech identified what we now know today to be photochemical smog, and his name was A.H. Hagen-Smith. This is just a basic overview about what happens in the process of photochemical smog, and we'll go more in depth into this. But I just want to give you a visual before we go into it. So basically, NOx and volatile organic compounds get broken down by heat and sunlight, and they produce ozone. And so this ground level or bad ozone is not emitted directly into the air, but it's created by chemical reactions. And emissions from cars, from any sort of industry, they're the sources of NOx and volatile organic compounds. And we'll see all the different effects of that throughout the presentation. Also, there's an animation on the next slide, and it starts right away, so I just want you to be aware of that and look at that, because we're going to watch that before I start talking. So you can kind of see the process of what happens. Volatile organic compounds and oxide of nitrogen from vehicles occur in the morning, and they're transported by winds. And they produce smog because they're broken down by sunlight. And then these fine particles reduce visibility. Well, basically,
Oh, it stopped.
well, basically what happens is there's photolysis of NO2 leads to the formation of ozone. And NO2, basically what happens in photolysis is NO2 absorbs UV light from the sun and is broken down into NO and O. And ozone is formed when this oxygen reacts with oxygen gas. And VOX in the air leads to an accumulation and high concentration of this ozone in the atmosphere, and forms toxic products.